number 9 is looking at asking us to determine a vector equation for a plane that is perpendicular to this line and includes the point. Okay, so if it's perpendicular to this line, right, what that would look like is here's our plane, and the line that's given would go sort of right through the plane. Right, so that line would be perpendicular to the plane. Okay, what that tells us is that this vector here is going to be our normal vector. Right, so the direction vector of our line is also going to be our normal vector. So we can write out that our normal vector is 1, 1, negative 2, and that tells us that our scalar equation then oh, sorry, I'm thinking of a scalar equation. So that tells us our normal vector. So determine a vector equation for a plane that is perpendicular to that line. So what we want is we want two different vectors that are perpendicular to the normal vector. So really what we're looking for is 1, 1, negative 2, dotting that with a possible direction vector, let's say 1, 1, k, and making that equal 0. And that would be 1 plus 1 minus 2k equals 0. So k would be equal to 1. Okay. So then the vector 1, 1, 1 is a direction vector. Okay. If we do that same process again, 1, 1, negative 2, and dot that with, let's do something quite different, 1, 0, okay? Oops. And set that equal to 0. We're going to have 1 plus 0 minus 2k equals 0. So k is going to be equal to 1/2. So 1, 0, 1/2 is also a direction vector. And so now we have two direction vectors, so we can write out our line. It would be x, y, z is equal to, we know the point, it tells us right in the question, 1, 2, negative 2 is on the line. And then we're going to go plus t times one of our direction vectors, 1, 1, 1, plus s times the other, 1, 0, 1/2. Okay, and that would be a vector equation of a plane that is perpendicular to the line that's given. Okay? And again, the reason we know that it is perpendicular to the line that's given is that these two direction vectors, when we take the dot product of them with the normal vector that's given, they're equal to 0. Okay? That's how we know it's perpendicular. Okay, and then finally number 10 says, determine how the two lines below relate to each other. If they intersect, determine the points of intersection. If they do not intersect, explain why. Okay, so when we look at the direction vectors, we can say 1, 1, negative 2, and 0, 2, negative 1 are not parallel. Okay, so that's one of the first things that I need to say. They're not parallel. So then what I want to do is I want to set up my first two equations. Let's do x and y. And so x is going to be negative 3 plus t is equal to 3. Okay, and then y is going to be 2 plus t is equal to negative 5 plus 2s. Okay, and what I'm doing is I'm setting equation 1, right, I'm setting equation 1 equal to equation 2. Okay. So from the very first equation, I can solve for t, and I can say from here that without doing any addition or subtraction, there's other ways to solve, but here right away I can say that t is equal to 6. Okay. And then if I sub that into here, so if I sub that in, I'm going to get 2 plus 6 is equal to minus 5 plus 2 times s. So I'm going to get 8 is equal to minus 5 plus 2s. 13 is equal to 2s. S is going to be equal to 13 over 2. Okay. So once I have t and s, what I want to do is I want to now check z. Okay, so z is going to be 8 minus 2t is equal to 1 minus s. Okay, and so if I sub these in, I'm going to get 8 minus 2 times 6 is equal to 1 minus 13 over 2. And so what I'm going to find is that this is going to be negative 4, and this is going to be negative 11 over 2. Those are not equal, so we can then say, therefore, the lines do not intersect. Okay. And if the lines do not intersect, we can then say lines are skew. Okay. And that's sort of where we've gotten with page 4. Okay. And that's sort of a sample test for this unit.